All right, page 3 of the study guide, we're going to start by converting from hold on, let me rephrase that. We're going to start by converting from radical expressions to rational exponents and vice versa, so work back and forth. So problem number 19, part A, I'm going to zoom in. And what I want to identify is each one of these pieces, the 16, the A, and the B, all have powers. 16 has a power of 1 that we just don't talk about much. And we have an index value here of 4. So each one of these pieces, we're going to do 16 to the 1/4, A to the 6/4, B to the 8/4, and you have successfully rewritten the expression with rational exponents. That's all you need to do. All right, so problem number 19, part A is done. I'm going to slide on over to number 19, part B. Again, I want to identify the exponents for what I've got. So in this case, we've got a 9 with a power of 1. Now, one thing to pay attention to is this root does not have a written index value. We assume it is a 2. So this is going to be 9 to the 1/2 and v to the 5/2. All right, so each one of these has the power over index, and that's how you do the rewrite. For problem number 20, we're going to reverse it. So one of the things that you're going to notice is all 3 of these have the exact same denominator of 3, which means we're going to be talking about a third root. And what we want to do is write down what's left over. So A to the 1st, B to the 3rd, C to the 5th. Make sure your radical extends all the way over everything. So you'll notice I actually had to add a little piece to my radical because my handwriting got a little large. And there you go. You've rewritten the expression with in radical form. All right. Number 20, part B, I want to look for my exponents, or not my exponents. I want to look at my index here. So all of those denominators are 2, which means we're going to be talking about a square root. Now, you can either just write the radical symbol, or if you wanted to, you could put an index of 2. It is totally up to you. Since I wrote the index of 2, I'll go ahead and leave it. We've got x to the 1st, y to the 5th, and z to the 3rd. Now, one of the things you might notice is I'm not actually writing down the power of 1. I'm a mathematician at heart, so if I don't have to write down the power of 1, I'm not going to. And in this case, I don't have to. All right, so that's converting between radical form and rational exponents. For number 21 through 26, we're going to be solving, and we're going to have to check for extraneous roots. So I'm going to go ahead and zoom in on number 21 here. So first thing I want to do is find my radical. There is my radical, and I am going to isolate that radical. So in this case, I'm going to subtract 6 from both sides. So we've got the square root of x minus 1 is equal to -1. I now want to get rid of the square root, so I'm going to do that by squaring both sides. So square and square root cancel. X minus 1 is equal to -1 squared is 1. I still want to solve for x, so I'm going to add 1 to both sides. So I'm going to get x is equal to 2. Now, part of the issue here is we absolutely have to check our answers. This is not optional. So down here, I'm going to put a little check. And what you're going to check is take this value for x, go all the way back to the original given expression, or the original given equation here. So we're going to check that x minus 1, so 2 minus 1 plus 6 is equal to 5. Use a calculator if you need to. Do whatever you need to check this work. So 2 minus 1 is 1. Square root of 1 is 1. So we've got 1 plus 6 is equal to 5. So I'm getting a statement that says 7 is equal to 5. Last time I checked, that is not a true statement. So this is false, which means that this answer is not the correct answer. It is called an extraneous solution or extraneous root. That was our only possible answer here. So because we have eliminated that answer, the answer here is no solution. There is actually no value that will make that equation work. All right. And that's what we're going to do for all of these. We're going to find a solution, or solutions plural, We're going to check our work and see if it's okay. All right, so number 22, I'm going to find my root. In this case, it is the cube root of x right here. And I need to get rid of all the extra stuff with it. So I'm going to subtract 16 from both sides. So I've got 2 times the cube root of x is equal to negative 16. I am going to divide both sides by 2. So I'm going to get the cube root of x is equal to negative 8. I am going to get rid of the cube root by raising everything to the third power. So cube root and cube cancel. I'm going to get x is equal to negative 512. Yes, grab a calculator for those things. Desmos works for that too. In fact, at some point I will probably split screen with Desmos. But I don't know if that's actually my answer or not, so I need to check it. So again, we're going to take this answer for x, go back to the original problem before any changes were made to it. So we're going to do 2 times the cube root of 5, whoops, there's a negative 512 there, plus 16 is equal to 0. So the cube root of negative 512 is negative 8. So 2 times negative 8 is negative 16 plus 16. So we're going to get 0 is equal to 0. That is a true statement. Because this checks true, I now know that this is the correct answer. So yes, x does in fact equal negative 512. All right, moving on to 23. I'm going to find that radical. In this case, it's the square root of x minus 6. I am going to, in this case, get rid of the 4, so I'm going to divide both sides by 4. So square root of x minus 6 is equal to 2. To get rid of the square root, I'm going to raise both sides to the power of 2. Square and square root cancel out. X minus 6 is equal to 4. To get rid of a minus 6, I'm going to add 6 to both sides, and I'm going to get x is equal to 10, but I have not yet checked my answer. So I'm going to check my work, and that again goes back to the original. Don't try and skip steps here. You've got to go back to the original to check. So we're going to have 4 times, let's see, 10 minus 6 is 4, the square root of 4 is 2. So 4 times 2 is 8. Yes, 8 is equal to 8. That is a true statement. Okay, folks, get used to checking your answers with these. This is not something that you're going to figure out or learn later on. Oh, Miss Curran didn't teach me a step. No, I'm teaching every step, and one of the steps is you have to check your answers. All right, I have to check my answers. It's just how it works. All right, problem number 24. I am going to find my root. In this case, it's the square root of x, and I want to isolate it. Now, what's going to make number 24 a little tricky here is because we've got x's on both sides, we need to make sure that when we do the next step, we are paying attention to all the pieces. So I've got the square root of x is equal to x minus 2. I am going to square both sides. So square and square root cancel out, x is equal to. Now, if you need to, put it off to the side. X minus 2 squared is the exact same thing as x minus 2 times x minus 2. Distribute, multiply, however you know how to do this multiplication, but get it done. So x squared minus 2x plus 4 is going to turn into x squared minus 4x plus 4. All right, it is a quadratic equation. So I need to get one side equal to 0. And then factor if I can. So I'm going to subtract x from both sides. So x squared minus 5x plus 4. That is factorable. X minus 4, x minus 1. I was trying to multiply to a positive 4 and add to a negative 5. Negative 4 times 1 is positive 4. Negative 4 plus negative 1 is negative 5. So take each factor, set it equal to 0. And each one of these is going to get me a possible answer. So x could equal 4 or x could equal 1. However, I have to check my work. All right. So off to the side here, I'm going to do my check. I'm going to check, x equals 4 first. It doesn't matter which one you check first. You have to check them both. All right. This particular problem, when we get two answers like this, one of them could work, both of them could work, or neither of them could work, and you're not going to know until you check your work. So I'm going to check 4 first. So the square root of 4 plus 2 is equal to, so every place I had an x, I replaced it with a 4. So square root of 4 is 2 plus 2 equals 4. Yes, 4 equals 4. That is true. So I now know 100% that x equals 4. That doesn't tell me anything about x equals 1, so I need to check that one next. So the square root of 1 plus 2 is equal to 1. The square root of 1 is 1 plus 2. So I'm getting a statement that says 3 is equal to 1. That is false. All right, 3 is not equal to 1 no matter what, which means that x equals 1 is called an extraneous solution. Eliminate it. Just get rid of it totally. All right, so number 24 is all done. I'm going to slide on down to number 25 here. All right, number 25, I'm going to find my root first, which is right there. I want to get that root, the radical expression, isolated. So I'm going to add x to both sides. So x minus 1 is equal to the square root of x plus 1. The radical is now isolated. I'm going to square both sides. Okay, so square and square root cancel. I've got x plus 1 on the right side. On the left side, x minus 1 squared is the same thing as x minus 1 times itself. So that's going to be x squared minus an x, minus another x plus a 1. So x squared minus 2x plus 1 is what that turns into as a trinomial in simplest form. I need to get one side of this equation equal to 0. So I'm going to subtract x and subtract 1. So those are going to cancel out. I'm going to get x squared minus 3x. Now the plus 1 and minus 1 are going to cancel, so they're gone. This is equal to 0. I'm going to factor this looking for a GCF. So x is my GCF. X minus 3 is what's left. Set each factor equal to 0. And I'm going to get two possible answers. X is possibly equal to 0 or x is equal to 3. I don't know if either one of them or both of them work. So I'm going to take both of them and I'm going to check my work. So let's check 0 first. So negative 1 is equal to the square root of 0 plus 1 minus 0. Right? Every place I had an x, I've just replaced it with 0. So negative 1 is equal to, let's see, 0 plus 1 is 1. The square root of 1 is 1. So 1 minus 0, I'm getting negative 1 is equal to 1. That is a false statement. I am going to go ahead and immediately eliminate x equals 0. It's an extraneous solution, does not work in this problem. Let's check 3. All right, so negative 1 is equal to the square root of 3 plus 1 minus 3. So 3 plus 1 is 4. The square root of 4 is 2. 2 minus 3 is negative 1. So I get negative 1 is equal to negative 1. True statement. So x is equal to 3 is the solution to that problem. All right, last problem on this page, problem number 26. So we're going to find the root. The root is already isolated here. It just is already. So we're going to get rid of the square root by squaring both sides. So 9 is equal to 2x. I'm going to divide both sides by 2. So x is equal to 9 over 2 is the answer that I would write because I'm okay with fractions. If you actually throw it in your calculator, you get 4.5. All right. Now, I've already got what x is equal to. What I don't have is the guarantee that that's the right answer. So I'm going to check my work. All right, so 3 is equal to the square root of 2 times, whether you do 4.5 or 9 over 2, it doesn't really matter. So this is going to be 3 is equal to the square root of 9. So 3 is equal to 3. That is a true statement. So whichever version of x you want to give me, whether it's 9 over 2 or 4.5, you could even write 4.5. That's the exact same thing. So I hope you've kind of gotten it, if you've been paying attention for all these, that you have to check your work. If you have not done that yet, you have to check your work. So make sure you're doing that. If you have any questions or concerns, please let